Thank you for joining me on exercise 2A. I'm going to be looking at question 8, and it says to use calculus techniques to determine the exact coordinates of any stationary points and use the second derivative to determine whether it's a maximum, minimum or horizontal inflection. So y equals x plus 5 over x. I'm going to get this ready to derive by taking that x to the b negative 1. So we get our stationary points by that dy dx equals 0. So dy dx will be 1 plus, and negative 5 times 1 is negative 5, x, and drop that down to negative 2. So let's solve this. 1 plus negative 5 over x squared. I'll bring that negative 5 over to be positive. I'll take that x squared up to be multiply. Take that square across to be plus and minus the square root of 5. So there are two places when this is stationary. And let's get the y value for negative root 5. Y equals negative root 5 plus 5 over negative root 5. So we've got negative root 5 plus negative root 5, because root 5 would cancel, right? 5 is root 5 times root 5 over root 5, so root 5 would cancel. So we've got negative 2 root 5s. So the stationary point is negative root 5, comma, negative 2 root 5. All right, let's find out when x is positive root 5. So we've got positive root 5 plus 5 over root 5, which is root 5 plus, and root 5 would cancel because 5 over root 5, that root 5 could cancel. So we've got 2 root 5s. So we've got a stationary point at root 5, 2 root 5. Now we test these in the second derivative to find out if it's a maximum or a minimum. And let's go up here to b. Here's our first derivative. So our second derivative would be, the derivative of 1 is 0, and the derivative of negative 5 times negative 2 is positive 10, x, and that's negative 3, which is 10 over x cubed. So when x is negative root 5, we have a value of 10 over negative root 5 cubed, and that's a negative, positive over a negative, therefore it's a negative. So it's concave down, and it would be a maximum at the point negative root 5, negative 2 root 5. So that's a maximum. And you substitute positive root 5. So it's 10 over root 5 cubed. And that's going to be a positive. So positive's concave up, which is a minimum. Concave up. So at root 5 to root 5, that is considered to be a minimum. And let's just say there's our two values. We would call them, by the way, they're not minimum of the graph, they're actually more local minimum and a local maximum. Not the actual minimum of the graph, but a local maximum and a local minimum stationary point. I hope this has helped. Until next time, stay happy.